Am I there? Okay. Good evening, everyone.
Good evening.
Welcome to Euler's birthday, the Global Graph Day. My name is Brijraj Singh. You can call me Brij. I'm a senior software engineer in the commercial software engineering at Microsoft. Here's my birdie handle, and this is my email ID in case you want to get in touch with me after this talk. I would anyways share the PPT with Augustine here, and he could share it further.
Thanks.
So don't need to take any notes. We're just going to have some fun with the graphs today. This is a rough agenda. We'll talk about how one could represent data as graphs. We'll talk about how do you model with the graphs. We'll talk about installation of the Neo4J. That is the topic, that is the particular technology we are going to discuss today. We'll see how you could load data in Neo4j. We'll take a look at the query lingo for Neo4j, that is Cypher. We'll probably also take a look at another query lingo, that is Gremlin. We'll talk about cloud. How do you host the graph databases in cloud? And that's where we'll probably touch upon Azure a little. And at the end, we'll have some fun. Yeah, and that's what all of us are here for. So to start with, are these graphs? Does these look like graphs to you at all? Are they? They are charts. Yeah, these are charts. Pie chart, bar chart. Most of the normal people out there, they think that these are also graphs, but they are not graphs. These are basically charts. Euler in 1736 somewhere studied this problem in the Königsberg town. The Königsberg town had Pregel River going through the Königsberg town, and there were certain interesting places on either side of the, either side of the river, and they had 7 bridges which are connecting the pieces of land. And the problem was that can you actually get back to a place, starting from a place, travel through each bridge only once, and return back to the same place? He studied that problem. And what he came up with was, he actually created a graph model for that. And he actually found that there is no resolution to this problem, basically. And he gave the Euler theorem that all of us studied in our 9th standard, 10th standard, and 11th standard. So how could you put data on graphs? This is the most natural way to put relationship, right? And that's what all data is all about. You have relationships in the data, and that's where we have studied RDBMSs and all. But if you see this is a very natural way of understanding the data. Ram is brother of Lakshman, and so is Lakshman, brother of Ram. And you have Sita, she's wife of Ram, and Ram is husband of Sita. Obviously, there is one particular relationship here wherein Sita is sister-in-law of Lakshman, but we haven't drawn another edge here. So there is a relationship that we missed recording, but there is certainly a relationship here. And this is a named relationship, so to say, right? I'm not going to talk a lot about mathematical concepts here, okay? So I'm just going to be easy on you. I'm not going to talk about degrees and all that stuff. Although if you're talking about Euler, you should talk about degrees and stuff. Yeah. But I'm going to give it a pass today. Okay, we're going to be easy on that side. I was never good in math anyways. So yeah, data on graphs. The edges themselves, they also can have a label as well as a property, as you can see. Ram has a relationship. He's husband of Sita, and obviously he's in that relationship since past 15 years or so. And so is vice versa. But the nodes also can have their own properties. So the node can also have properties like name, gender, and whatnot, right? It's the similar graph represented with the help of the labels and the properties. Now look at this information. This is how we represent information nowadays in the databases. So let's say that Dr. Verma here is having an ID of 411, and he is the doctor of 327, that is Robin, right? This is how you represent information nowadays, that you have IDs, and then you have a table wherein you relate IDs to the other IDs, right? And Dr. Sharma here, who has an ID of 397, he is the doctor of 327 as well as 999, that is Neetu here, right? If you put this information, actually what you're trying to do is you're trying to fit in the information somehow, and that trying to fit in actually gives rise to a problem called impedance mismatch. The data was not supposed to be in this form, but you tried to put it in this form, right? Because that's the only way you knew it. This is, in fact, a rather easier way of looking at that data, right? Is it not? It's direct relationships, you can see that, right? So your Dr. Sharma is directly related to Robin and Neetu both, while Dr. Verma is directly related to Robin only, right? So the information is correctly represented, if you ask. When you go out there, you see that the graphs are everywhere. On the left-hand side, you see an example of a Delhi metro map, which is basically a really good example of graph. On the right-hand side, you see that I think this is America's area, wherein you're seeing all the flights connecting to each other, right? This is a really good representation of graphs out there. They're everywhere, wherever you see them. It's just a matter of representing them and using them in the right spirit and the right way, with the right kind of tools, of course. You could actually store all of this information in a normal relational database as well, but that's not something which is the best way to do that. Right?
Actually, this is a good time to take a photo of that previous one.
Yeah.
I see, because the decal is there, right?
Okay.
Graphs are everywhere.
Oh yeah. So yeah, the graphs are everywhere, of course. Okay. So how you should model your data the graph way? If I'm going too fast, just let me know. Okay. This is one of the graphs. You would see this graph in a while in the real live system. But this is a graph from Mahabharatha, the relationships between the Pandavas. As you can see that Pandu is husband of Kunti, and Kunti is mother of Bhim, Yudhishthir, Arjun. Obviously, this is not the complete Mahabharata graph, that would be too messy. But yes, I've tried to bring in the relationships that I could come up with really quickly. And Yudhishthir is the husband of Draupadi, and you can see that Draupadi is obviously wife of many other people out here. No offense, right? So you can see all those relationships here. This is a nice way to put data, but you can also see that all of them are persons. They are of a certain kind. They are persons. If there was something else, like something which can be recorded who's not a person, that can also take part here, of course. But this is all full of persons only. Every one of them has a particular ID. They also have certain properties attached to them, like name and gender and whatnot. Internally, it will all be running through the ID. So every time you create a node, you get an ID on that node. The relationship, although, can be in and out, or both, right? So you can have a relationship that is going out, and you can have another relationship that is coming in, and you can query accordingly. You can actually do a traversal on the graph, right? Just like the way we used to do when we were in our, high schools.
Yeah.
So talking about this particular tool, the Neo4J, that is the graph database, how you should install and all that stuff. I'm sure you can get it on GitHub as well as on the Neo4J website. You can get it from there. There are two kind of packages, and it's available for Windows, Linux, and Mac OS X. It's a pretty popular, one of the most popular tools out there when you talk about the graph databases. And what I love about is the technology. The technology and the programming language. Cypher itself is an amazing programming language. We'll be using that a lot today. Running Neo4J is really easy. We'll see that in a demo shortly. It runs on a local port. You have properties that you can configure, and they are available in these locations. You certainly need OpenJDK or Oracle Java, but if you already have that in your machine, it will just install easy peasy for you. Azure, I'll give it a pass for now. Monitoring, you can also do monitoring of your system. When we'll move to the demo, we'll take a look at it, but yes, it can show you how much is allocated to the IDs, and is it high availability, is it running in a cluster, and yes, you can do transactions as well. Okay, so this is ACID compliant, so to say, but not fully. So when you read it, you will find that there are problems. So if you want to make it like full ACID compliant, then yes, you would run into having a very slow system out there. It's not going to be as good as it could be. There are tons of developer interfaces. It's available on REST API, .NET, Java, you name it. Okay, so I'll just not bother you with this much. Okay.
Okay.
So loading data again is really easy. I have already loaded some data over here, so you can actually bring in a CSV file and you can load it up. I'll show you some of these CSV files in a demo soon. And inserting the data is as easy as running a query like this, which is just actually a create query. So we'll take a look at this as well. I'm actually giving everything a pass when I'm doing the PPT. We'll do a demo rather. A cipher is a declarative pattern matching language, which we will be using a lot today. It has quite SQL-like syntax, and it is specially designed for graphs. That being said, this is not the only language out there. There is another imperative version of graph query languages, things like Gremlin, wherein you can actually write imperative code. So we'll probably take a look at that too.
Yeah, Cosmos works on that.
Yeah, that's what CosmosDB uses. So you see Cypher, you basically focus more on, this is one of the patterns. So if you want to match a husband of and be, and you say returns both husband and wife, right? This one is just going to return both husband and wife. The other query, what do you think it should return? Anyone?
No.
It will return the husband only because it's returning A only. The second one is going to return the B only, right? That's the B. Wife, yes. We are not taking care of a lot of diversity of genders here, by the way. So we are assuming there's a husband and a wife. Okay. This is going to be exciting. Now, one of the cool thing about the graph databases is that you can actually do shortest path queries. Now, this is the shortest path query wherein we are trying to find out a relationship between Sahadev and Abhimanyu. Yeah? So, relationship is quite easy here. Sahadev is husband of Draupadi. Draupadi is also wife of Arjun, and Arjun is Subhadra's husband, and Subhadra is Abhimanyu's mother. The similar kind of query, if you were to write, would take you this much of code in SQL, right? And writing that, anybody who knows Cypher can write it. But anybody who knows SQL cannot write this version. This is certainly a very difficult thing to do, right? So certainly, if you are to do paths, traversals, and such kind of relationship-based queries, graph databases are probably the best way to do it, rather than depending on SQL. Okay, demo time. Okay, we have quickly jumped into that. So if you open Neo4J, you will see the first time you would install, you will have an option of adding a graph. Oh, sorry, am I not displaying? Sorry, I'll reconnect. After installation, you will find that there's a Neo4j browser, and you'll find that there are options to add graphs. At any point of time, you could be running one particular kind of graph, okay? So I have 3 graphs installed over here. I have a movie graph which comes out of box. So if you say, if you do a query like :play movie, that movie graph thing would start running, okay? So let's just start with this for now. So I'll just open the Neo4j browser, and we will basically just go back and play it. We will start learning. So this is our movies tutorial. So this actually shows you how you should be able to create the data. So if I go through this, you will find that it does a lot of create queries here. Yeah, so it says create metrics, movie title metrics. It's actually creating the movies as well as it's creating the people who acted in those movies, right? You take this notch above, download some data from IMDb, and bang, you can actually make a game wherein you can find out who is related to which actor, by just acting in the movies. So I remember about 5 years back, I made a game, Bollywood Ki Kasam. So you can actually just put two actors there, and you can find out relationship, how these actors are related to each other. Okay. And this is how you actually create those relationships. When you go here, you say create. Keanu worked, his role was Neo, and he worked in Matrix. Yeah. So if you were to just open this, let's say do match and yeah, so these are all the relationships that we have just created and all the actors that we have just created. Yeah. And maybe JavaScript could be a little bit broken. Yeah, but you can see all these relationships, like what dreams may come. Like this is a movie node, which is connected to, like, as good as it gets, also is connected to all the actors or the directors who have worked in for that movie. But this is something that you can find always cookie cutter, right? I'll show you something that I have done with the data. So I'm just going to close that.
Should I do background music?
Ta-da! Shri Mahabharat Katha or Game of Thrones?
Whichever.
Okay, your choice. I'll give you a choice. Game of Thrones or Mahabharat? Which one would you pick? Huh? Game of Thrones?
Why is awesome today? Because it's getting released today.
Yeah, I love Game of Thrones. The season 8 just released the final season. So let's just go ahead and start with Game of Thrones. So this is a database. I have actually generated this database. I'll just go back to so I'll show you my so these are the queries that I actually prepared. Obviously not by hand, because keeping track of so many people who worked or been in Game of Thrones and their relationship with other people is not so easy. So I actually went through the internet, find out the relationships, dumped them in a CV, a CSV, and generated this, query sheet. This will be up on my GitHub in a while. I'll share the link with you. So you can see there are a lot of people who are here, and there are people you probably don't remember about them, like first Hai Sachin, right? Which house does he belong from? Is he dead? Is he captured? I should actually include one more tag here, is resurrected.
Yeah, resurrected.
Yeah, because
actually he's dead where? Which season?
Yeah, yeah, end season. Yeah, that's a good idea. One should do that. So a lot of them, and I don't claim that I have everything correct here, because this was correct till season 5. So I picked up all that information, created relationship of as many people as I understood, remembered, and it's also available in form of a CSV file if we were to take a look at it. And I have the scraper and everything written over here. I would probably not share the scraper with you because I scraped data from websites that I don't remember anymore. Yeah, so you can see the relationships here. And at some point of time, I maybe realized that you need relationships with numbers. But anyways, so let's just move to our Game of Thrones database. So let's go here and we do action. Call and bang. This is our system. You can see that, wow, this is something interesting, right? There is Targaryen, Jorah Mormont loves her, Daenerys Naharis loves her, who else loves her? Okay, and she has got these dragons, the Rhaegal, the Drogon, the Viserion. She was wife of Drogo. Aerys Targaryen was her parent, and Viserys was also her. Viserys was her brother, I guess. Yeah, and this is the bloodline as much as I could capture. The more interesting part is this, wherein the Lannisters family got connected to the Stark family, right? Now, if we were to find a relationship between, let's say, between the Lannisters and, maybe like Baratheons and the Starks, right? That's like a far relationship, right? The only connectivity that you would get probably through here, right? So let's try some of these combinations for ourselves. Yeah. So I'll just pick up my shortest path query. Okay. And just is this a little? Let's just try to. Okay. So let's first try to find out Tywin with Arya Stark. Okay. Let's try to do that. So click on Tywin. Tywin's name is Tywin Lannister. And we are going to connect it to Arya. This is the name. Arya Stark. And we'll try to find out, is there a relationship between Tywin and Arya? Jeez. We're missing something. Where is Arya?
With this Sansa.
No, we'll want to use Arya only.
No.
Okay. There's a. Okay. Alright.
No. No, really
Is
never.
there some expected white space? I'm doing some mistake here, of course.
When person also, Arya person.
Yeah, Arya is person. There is some probably a white space that is missing here.
No, return should have a space, I think so.
Yeah, return should have a space. And I was
Return has a space, and that Arya person should be in the curly braces.
I think it is.
No, Arya person curly brace.
No. Wait. Wait a second. I've done this. I should have it. Yep. There it is. So this is our query. Yeah. So this is how Tywin and Arya are connected. Tywin is the parent of Tyrion. Tyrion is the spouse of Sansa Stark. They got married. It was not a good marriage, but it was a marriage. And Catelyn Tully is the parent of Sansa and also a parent of Arya. Yeah. Now we can take it further and actually try to find a relationship with somebody like, I don't know, some Baratheon we were talking about. Yeah.
Mm.
So we'll pick up probably
Robert Baratheon.
a Baratheon or Renly. Renly is too far, I guess. Yeah. and that too also worked. Yeah. Arya is Caitlyn, Caitlyn's Sansa, Sansa to Tyrion, Tyrion to Tywin, Tywin to Cersei, and yeah, that's a bad relationship, by the way. I made a mistake here in the relationship. She had, yeah, no, that's actually fine. She was the parent of Tommen, and Tommen was married to Marjorie for a while, and Marjorie was obviously spouse of Renly Baratheon as well. So yeah, this is good. What you can see is that in this particular query, I actually didn't change the label name of Tywin here, purely because I actually didn't need to, but this is just like labeling something so you can refer it again and again. If you remember in the first, we had a query wherein we had return A, comma B, so you can actually just label it as A and B, and it's totally your call to do this kind of a relationship. You can take this further and actually just go ahead and make a game for yourself, wherein people can guess if they have a particular relationship, how are two characters related to each other. So this is one set I have. I hope you liked it. I have another data set here, which is obviously Mahabharata. If you see that Game of Thrones had 301 nodes and 77 relationships, this is not that big anyways. This has just...
I mean, your Mahabharata is not that big.
Yeah, my Mahabharata is not that big. Yeah. This is something that was done really quickly. So I did not actually end up writing a scraper for this because I know Mahabharata, of course. So I know the relationships between people anyways. So let's do a run of this here, and then we will move to cloud and see how the similar data is represented in cloud in the CosmosDB.
So these Spotify relationships you have to create manually. All these relationships which you have to define.
Yeah. So generally you should do that in maybe in a CSV file. The relationships. So if I go back to Mahabharata, okay, I didn't actually create it, the CSV. I don't remember having it now. But yes, you actually should keep this in a CSV somewhere, like we had one for the Game of Thrones. So you can see I actually ended up creating a lot of CSVs here because I was playing with the code. So what you do is that you actually try to name the people and you try to put a relationship, right? And then maybe you could generate a query like this, okay? This is the only way to bring data in, okay? So either you generate a query or you load it from a CSV, okay? Either way is good. You can actually bring data from CSV. So that's a affirming thing. So you have nodes and the relationship, that's it. And so first node, second node, and the relationship, that's like node 1 to node 2 relationship. If you want both, then you record it twice, okay? Then obviously you reverse it, right? So this is one of the relationship examples. So I can give this to you. This is just fine. Okay. I have a special sheet that only has characters. So this is my master sheet, by the way, which has got character information. So you create characters first, and then you create relationships between them. And Neo4J do not expect you to remember the ID of the characters, so to say. So you can actually just name the character, just like we were doing that, right? So match this to this, and then create a relationship between them. This can go as extensive as you want it to, right? So I have about I don't remember, 301 relationships, 301 characters over here recorded. Obviously, I scraped them from somewhere, so that information is as good as that website was. But yeah, we can certainly take it forward from here. So anyways, back to Mahabharata. Let's see if that loaded. So yeah, Mahabharata is loaded. We can also go back to that. It's the same browser, okay? I can go back to the same browser. There's that. Yeah, this is our browser. Let's do one more query here. Okay, that's our Mahabharata graph. Okay, very complex relationships. There are people who are not related to anyone, although they are in real life. They were like Drona and Drishtatyumna. They were certainly connected to other people over here, but they are not recorded here, obviously. So they are solo nodes. There is no way you can reach them, right? I should have created a relationship when it was like disciple of or teacher of, something like that. Then you can travel through it, okay? Sometimes you will find that you have to specify the direction of the relationship, okay? So just make sure that you have both directions if you want to do the traversals on both sides, or you will have to include in your query that you want to do both traversal, right? So like Jayadrath here is not connected to anyone here. Anyway, so this is your database for now. Quite complex, getting quite complex. I just brought everything together. Do I have people who are not connected to anyone? And there are places where I have recorded people who probably you've never heard of, like Sweta, or I think Virat and Uttar, those kind of people. But yeah, I tried to bring as many people as I can. So here, getting the similar kind of relationship is again something we can do. So we'll pick up some code. No, I don't think we'll do that. We'll just go ahead and write our own. Okay. So we had our, let's just change our query. So we'll pick up, who do we pick? Let's say Vichitravirya. You know who's that? Vichitravirya?
Who is it?
Vichitravirya.
No, I mean asking people, who is it?
You don't know? Okay, there were 3 princesses. Bhishma Pitama abducted and brought them to marry his so-called brothers from another mother, right? So Vichitravirya was one of those brothers, and he was married to Ambika. So there were 3 sisters, right? Ambe, Ambika, Ambalika. And one of the sisters became Shikhandi in the next life. Yeah. So he married one of his brothers to that, another brother to another sister, but the third one was remaining, and she became Shikhandi because she could not marry anyone, and she cannot go back home. So anyways, yeah, that's it. So we'll try to match Vichitravirya, and we'll try to find out how Vichitravirya is related to, let's take an example, say, Nakul is a direct relationship, but yeah. Ghatotkaч, somebody like Ghatotkač. Yeah?
So I have a question.
Yeah.
Like you have a shortest path between 2 nodes, only 2 nodes.
Yeah.
But can you have a shortest path between 1 node and 2 more nodes, like 3 nodes, in one screen?
No. That doesn't make sense. Shortest path is between 2 people. So it's always going to be, you are talking about a problem wherein you want to do shipping, let's say, right? The shipping industry uses that a lot. So one of the use cases is Amazon itself, right? Or any other e-commerce delivery platforms. When they want to send product, right? Every day they create this kind of graphs, and they use these kind of technologies a lot, by the way. So they create these kind of graphs to optimize where to deliver first and where to deliver later. So you save a lot of fuel and you save a lot of time, and you try to make sure that you allocate in the proper area. But yes, you will also have to throw in a little bit of AI here. So if you just go by the by the distance between the places, that's probably not the best way to do it. Because at times you have multiple vendors delivering, and some vendors are slow deliverers, some are fast deliverers, some have a quota of delivery. They cannot deliver more than a certain number of packets, so you have to take all that in account.
Or you can have two paths in one single screen.
I don't get it.
Try to explain this, what
Yeah.
you're trying to do. Don't
Like
give a...
You have Dronacharya and Vichitra and Ghatotkač
Yeah,
and Arya.
yeah.
So you want to find shortest path between these two pairs. So can you show 2 pairs in one screen?
Oh yes, I mean do the 2 queries.
Two
And-
pairs in one screen. Two
Yeah.
pairs of
So this is
shortest
not about, so this is just one display kind of a screen. You can actually run two queries, one after another, and show them in one screen. That's just perfectly fine. Our friend here has got a display, a customized one. Augustine has a customized one, so you can show multiple charts there, right?
Yeah.
I don't think that's a problem.
So, have you filled the form, the URL I gave you? Confirmation?
Yeah.
Okay, so you'll see how you guys are all related to each other.
Oh, so perhaps after my
So for
talk.
this shortest path, is it using that Dijkstra's algorithm or something else basically?
A form of Dijkstra's.
Um,
Right. There are not too many shortest path algorithms out there anyways. So, yeah, so you can see that this is again, it's not the perfect relationship, so to say, but this is the shortest path it could find. By meaning of shortest path, that it means that it's not traversing through as many nodes, so to say. So, but there is no weight given here, so to say, right? If the weight was given here, that was a different thing altogether, right? Because it's not just about hopping through the nodes, it's also about the distance between the nodes, which is not a property right now. It's just labels and relationships right now, right? So we haven't given any value property, so to say. If you were to have a value like, forget about Ghatoj, Kach and Vichitravirya, let's say these were cities and distance between the cities, right? Then how do you reach from one point to another? By making sure that you don't have to travel a lot of distance. Then the number of cities don't matter. What matters is the weight between the cities, what is the actual distance between the cities. And that's one of the properties of your edges, right? Of course, the query then would be a different query. But yes, that too can be done here. So enough of this. Let's say that you were doing this in Neo4j, and I hope that it's okay if I take this now to cloud, okay? You can certainly run this at a scale. You can run Neo4j in a cluster, okay? Now let's say that you want to do this in a cloud environment. If you want to do this in, let's say, Azure, right? Neo4j actually provides their own machine images that you can actually run out of box in Azure, right? I'm not sure about AWS, but I'm quite sure about Azure. So we'll just go there and we'll take a look at those. Yeah. Okay. So okay, we're going to Azure. Let's say you want to create a new resource. Go here, you can search for Neo4j. Yeah, and you will see that there are multiple images out here. There are Bitnami certified images. Obviously, Bitnami does a lot. They pick up the open source images and they, certify them. You have Enterprise Edition, you have cluster images, you have Enterprise VM Edition, and you have a container image as well. So it's also available on Docker. So which is probably the preferred way of doing it nowadays, is that you run this in a Docker, right? It's lightweight, works just like a charm. You don't need to install anything, just pull the Docker image. Anyway, so you can actually just pick up any one of these and get started. And it will actually create a VM for you in which the Neo4j comes pre-installed for you. So that's one way of doing it. Another is, how do you do this cloud native? How do you do graph databases as cloud native? So one of the products that Microsoft has is called Azure CosmosDB. Now, Azure CosmosDB is a you can say it's a multilingual kind of a database out there. It is the NoSQL database by Microsoft. So you can actually do document data stores, you can do columnar data stores, you can also bring in graph data stores like the graph data that we have with us. So in this particular case, I have actually deployed a Cosmos DB instance for ourselves, which is called graph-a-n. And you can see that I have hosted this in West India. You get a URI as well, and you also get a Gremlin endpoint. So the query language that we were using till now, the declarative version of it, That's actually called Cipher, okay? And there are SDKs available for that. The query language that Microsoft's Cosmos DB uses is called Gremlin, okay? And this is the Gremlin endpoint. So if you have a Gremlin client installed on your machine, you can directly connect to this endpoint and start, working with it. But obviously, from security point of view, you'll need certain keys, and those keys you can get here, okay? So I'm sure nobody's recording these keys right now. Just quickly get away from here. There is an
recycle
online,
them.
Huh?
Or recycle them.
Okay, I will. I'll anyways delete this guy. Anyway, so there is a data explorer here, wherein you can actually take a look at your data. Before you create Cosmos DB engine, while you are creating, you can actually select what kind of engine do you want to run. So do you want to run a document data store for your JSON documents? Do you want to run a document data store with MongoDB API? Do you want to run a columnar data store, right? Give me the name of one columnar database.
Huh?
Really?
No.
Really?
Yeah.
Okay. I'll give you 5 more minutes to think. I'm sure you know a lot of databases. Just think about that.
Columnar.
Anyways. Huh?
Or not relational, right?
Not relational, the columnar.
Column.
Yeah. Anyway, so I'll give you 5 minutes. Just think about that. I'm sure you know that. You probably don't remember that this is the columnar
Like
database.
CSV is,
Huh?
CSV we have data in columns.
No,
No.
that's not what I mean. Anyways, so I'm coming back here. So you get a data explorer here as well, wherein you will be able to do the query on your data just in the cloud directly without installing anything on your machine. Okay. The best way to do it would be is to do it with the Gremlin. So of course you can connect the Gremlin to it. But I'm going to do everything over here anyways. And it gives me 2 options of doing queries. It gives me a SQL-like option, and it gives me the Gremlin option. Okay. Now I'm not a big fan of Gremlin, by the way. It's anyways an imperative programming kind of a language, and I find it quite tedious to write.
Is there a thing that you can convert Cipher to Gremlin? I mean, if you already know Cipher,
Yeah,
why work in Gremlin? Has that been part?
that's a good idea. I haven't come across anything like that so far. But what I have come across is you can actually port your databases directly from Neo4J to the Cosmos DB. Okay, so there's a guy who has written a piece of code, and I already have that piece of code with me. It's called Neo2Cosmos.
Okay.
Yeah. So if I put this guy, it's a very straightforward guy. What he does is he reads the rows, and he actually creates the proper Gremlin queries, which you can feed into, directly feed into. You just provide a source and a destination kind of a connection string, and you will have it going for you. So I used this actually to create relationships, the similar relationships that we had with us. Here is my app.config. Yeah, so you can see that we are talking about this particular database. This is the collection ID, the endpoint values of Cosmos. I gave the Neo4J username and password and just ran it. Okay, and it will create all the relationships, labels, nodes, edges, everything for me. Okay, just like that. This is a very nice tool if you want to, go forward. But it just does one way; it doesn't do the other way. So you cannot come from Cosmos to this.
All
So,
those clouds does that, I don't.
yeah, cloud is anyways one way. So one of the syntaxes that you can do something like this, like g.v. G.v basically gives you all the vertices that you have. Okay. This is going to get tedious anyway. So on the side you can see that you have the properties of a person, ID, label, name is captured or not. I'm just going to do a control. Oh God. Yeah. Why is it? Okay. So you can see that for this particular person, it's giving me all the properties. And if there is a connected person who is connected to some other people, then it will probably give you the relationships here as well, right? As you can see, Dario is connected to Daenerys, and it doesn't talk much about Daenerys from that point onward. So it doesn't actually gives you all the connected things together, just like the Neo4J was doing. But it is actually giving you, some direct relationships that it has with other people, right? Or you can do things like Turan Martal. Yeah. Now it doesn't actually load everything. You can see that it loads only a few because it knows that there could be too many items here. So it loads only a few, and you have options of loading others. This is your JSON of the similar things that you were just looking at in graph. Okay. Now when it comes to CosmosDB, everything is in JSON actually in the background, right? So you will find that you have all the JSON relationships here. Yeah, all the JSON data and all the JSON relationships. And it also gives you the query stats, that is how much effort is it taking, the request charge, how much value is it per unit, and because obviously you get charged on the queries, okay? You get charged by the requests that you make, you get charged by the data that you store. That's the cloud economy for you. If you were to do a similar kind of a query here, right, this is this much difficult for you. So I'll just pick one. So this is actually finding the relationship between Tywin and Arya, and you can see that although it is doing that, Tywin, Tyrion, and it's actually trying to find out the relationship, it's actually not doing the chart for me, right? This is something, a limitation of the tool itself. It's not actually limitation of the Cosmos DB. It's just a matter of actually creating that tool for yourself. But the actual response would be in form of JSON here, okay? You can certainly write SQL queries as well, right? And you can also create the new items for yourself here. You can see that if you can actually do a SQL query like this, select star from C, and if I do that, it gives me all of the items again as JSON. But yes, you can't do shortest path here again, because this is SQL kind of query, and this is going to be really difficult for you. Okay, but both engines will work. The SQL engine will also work. The Gremlin engine will also work. Okay, so it's up to you. Which one do you want to use for what purposes? Okay, so this is certainly very scalable. You can also do geo-replication at the click of a button, and you don't need to worry about maintaining your cluster, so to say, right? And by performance means as well, this is far, far superior when it runs in the cloud. But that doesn't bill until Neo4j. They have a really good query language out there, which is like way, way better than this one, I would say. Yeah, so these are a couple of demos I wanted to show you. I'm open for questions now.
Go ahead.
Do ask the questions. If you don't ask, then yeah.
So is there any particular advantage, like you have Cosmos DB by Microsoft?
Yeah.
Like how does it compare to Neo4j, which is open source?
So Neo4j is not completely open source, so to say. It has enterprise versions as well. Okay. So this is just, Cosmos DB is just giving you another option of a scalable graph database out there in the cloud. So I think scalability is just one of the things that you're going to get with the cloud, right? That is something, if you want to do on your own, it's a difficult thing to do. So if you are doing that in an enterprise, it is a very big task to maintain clusters and hire people and make sure that the duplication is done perfectly. That's a really big deal, right? So if you want to avoid that, then yes, go for Cosmos DB. If you're running some small scale systems and you just want to do some graphs, then yeah, why not Neo4j? If it's an enterprise application, you're running it in your enterprise data center, go for Neo4j. But if you want to go, to a very big scale, then yes, Cosmos DB is the way to go forward. Yeah, and of course, if geo-replication is also on the charts.
Okay.
Actually, depending on a partition key, you can get okay which can be closest also to you.
Yeah.
That is simple. Usually latency, because you do West India now. Suppose like I'm building a meetup and this meetup is 63, and if I don't pop a partition key,
Yeah.
he will be querying from West India, even the guy is based in California or something.
Right.
So we're gonna make sure the partition key is good. I think Manish will take that session in the Azure bootcamp.
Right. So Manish is the CosmosDB expert.
Yeah.
By the way. Yeah.
Any questions?
No. What sort of applications are they being used right now in these things?
Good question. So route optimization, of course, we talked about that, right? Forensics, certainly a lot of people in forensics use that because in case of forensics, the data just keeps coming in and the data relates to something at a point of time and sometimes it doesn't. It is hard to keep track of everything happening around, right? So forensics also use that a lot. Route optimization, as we talked about, I think these are a couple of use cases. If you go to Neo4J's website, you'll find that everywhere they will use graph databases. But yeah, it's up to where you find that relationships are getting too much and you need to traverse through the relationships. Then yes, it makes perfect sense to use something like Neo4J.
Anyone else?
There is also nowadays something called the GraphQL, which is used for talking to relational databases.
Yeah.
Is that something like similar?
Yeah, I'm not covering that today.
Okay.
Actually, it doesn't just
Yeah.
talk to relationship basis.
Yeah.
Basically, the way it's a Microsoft Facebook product.
Facebook part.
Okay, and they came out because they wanted to make their website talk. They talk to a lot of different APIs, right?
Right.
So the way to go is basically the front end just makes a query like email,
Yeah.
give me all this, and that's what happens in GraphQL. So basically, it's abstracting a little bit of complexity while you're building up your front end relationships.
Yeah.
That's it.
Okay. Thank you very
Okay,
much.
thanks a lot.
I have a few references here. I would share those with Augustine. We would like to share those with you
Yeah.
later. Thank you very much. And next would be
Yeah.
Achi.
But just we start up. We have also a video from Neo4J why she sets it up. No, set it up. You're setting up?
Come. Yes. So.
Hey, just disconnect yours.
Mine will disconnect.
Okay, I'm connecting.
Are you connecting to
Yeah,
that?
just give me 1 minute.
Do you want to connect?
I'm connecting.
Acha. 1, 2, 3, 4, 5, 6, 7. Oh, it's very safe. Are you connecting? You want to connect?
Yeah, just one. I'm connected.
Okay. No, this is actually for the video.
Yeah, that's 10 minutes. Maybe we can.
Hi, my name is Corinne Wallach, and I am a community manager at Neo4J. I'm here to tell you a little bit about why people all around the world are